It's very rare we see 3 videos in one section, but this section has so many formulas. So, right now, this video, it is I'm going to try to keep this short, but you have some product to sum formulas that you are going to want on your notes. They are relatively straightforward to use. So straightforward, I'm not even going to put our second problem on a different slide. What I have here is the directions. Rewrite the product as a sum or difference, and that's exactly what this formula does. It takes a multiplication, which we have multiplication right here, and we're going to rewrite it as a either sum or difference depending on the formula. So looking at us, we have cosine 5x, sine 4x. So you're thinking of this as 5x, you're thinking of this as 4x. And what I'm going to be able to do is I'm going to be able to take this right here, and I'm going to be able to expand it. I'm going to have 1/2 out in front. I'm going to have a bracket. It's going to be sine. I have to add up 5x plus 4x. Now, most people will probably do that in their head in future steps. But then we have sine, and it's going to be 5x minus 4x. We'll close our brackets. So what's our final answer? 1/2 sine 9x minus sine x. Final answer is like that. Again, it's all about using the formula. If you can use the formula, then you're practically done. Those are not like terms. You stop. You cannot combine sine of 9x with sine of x. They're done. They're not the same. Leave it as is. All right. So we have a product to sum formula. We also have a sum to product formula. So it takes, notice the difference, the order here. It takes a sum and writes them as multiplications. So we see that we see a difference here. And right now, I do not know the cosine of 195 or the cosine of 150. I could figure them out if I wanted to use my my half angle, or not some of my addition formulas that we learned last section. But here's a second method. Essentially, I have 2 cosines. This is a typo right here. That's supposed to be a plus. So I will be using this formula because I've got cosine plus cosine. And essentially, if I apply this formula, it's 2 times the cosine of 195 plus 105 divided by 2. And the cosine of 195 minus 105 divided by 2. And the calculations here, it's 2 cosine 195 plus 105 is 300. 300 divided by 2 is 150 times the cosine. That's 90 over, that's 45. And now it's just a matter of knowing my unit circle. I've got 2 times cosine 150 is going to be negative radical 3 over 2. And then cosine 45 is going to be radical 2 over 2. And I just multiply it. And when I say multiply, those 2's cancel. And I have negative radical 6 over 2. Final answer. One last problem. It's just one more application of our sum to product formula. Here I'll be using the top one that's right in your notes. And I'm going to, and because I actually have to find the solutions, I'm just going to modify this left-hand side. This left-hand side can be written as 2 sine, and I'm going to write this as 8x over 2. And I hope you know where I'm getting 8x. I'm adding those. So I'm going to write that as 8x over 2. And in fact, even easier than 8x over 2, it would be better to write that as just 4x. I hope I'm not skipping too many steps there. I still have to do the same for cosine. The difference for the cosine portion is I'm no longer adding. I'm now subtracting these 2 values. So I would be writing 2x over 2, but that simplifies, and it's easier to just write x equals 0. So what I have right now is 2 times sine of 4x times cosine of x, all set equal to 0. So what I'm looking at here is a multiplication that's set equal to 0. So I'm thinking 0 product property. I'm going to set up 2 equations here. And in theory, the 2, I could really divide everything by 2. So I can kind of ignore it. If you put it into one of your equations, it's not going to make a difference. The two equations we need are sine 4x equals 0 and cosine x equals 0. Well, the question is, sine of what values is equal to 0? Sine is equal to 0 at 0. So I could say 4x is equal to 0 plus 2 pi k. That would be one correct answer. There's also another place at 4x would be equal to pi plus 2 pi k. So if I solve this, I divide everything by 4. I have one of my answers here would be pi over 2k. That's essentially multiples of pi over 2. My next one is going to be pi over 4 plus pi over 2k. So this is going to be, if I was to list these answers out, I'll worry about this cosine piece in a second, but if I was to list these answers out, 0, pi over 2, pi, 3 pi over 2, I wouldn't list 2 pi because the way the directions are stated, see, I do not need to include the 2 pi. Over here, my first answer would be pi over 4 plus a half. That's going to be 3 pi over 4, 3/4, and then plus another half. I'm going to have 5/4. That's going to be still in the unit circle, and then 7/4 is on the unit circle as well. I wouldn't go to 9/4 because that's off the unit circle. I have one more place I can get answers, and it's from this cosine x equations right here. Where is cosine equal to 0? That happens at pi over 2 and 3 pi over 2. Now, if you notice, those answers are already stated and are already stated. That doesn't happen every time, but I have a large number of answers that would be all solutions to this problem. Oh, sorry, I should have just right there. All right, I'll see you in class tomorrow.